follows. So in that situation, we have that scenario. Then at this point, we ask ourselves, is our graph a negative one or a positive one? And that can only be determined by checking our original equation. So if you check this, everything, the product of this is less than 0. And anything that is less than 0 will definitely be what? Negative. So we know vividly that this point is our positive region, this is our negative region, this is our positive region. Automatically, since the content of what we have, the product of the content of what we have here, the product of the content is less than 0, that is negative. So we go to our negative region and shade. This is our negative region, we just shade this. So by the time we shade this, we realize that the 2 points are what? Convergent, they are meeting. You can see them. The 2 points are meeting. So if the 2 points are meeting, that means x will lie between those 2 critical points. That means x will definitely lie between 3 and 4. So go to our option and see the one that matches this. So, but we are not operating based on x. Remember, we are operating based on what? M. So this x will be changed to what? M. So M will lie between 3 and what? 4. So let's go to our option and see the one that matches that. That would definitely be option C. Now, the last question here, that's question 10, though we are still going to solve more of this question. And the essence is so that you get acclimatized with all the questions and how to approach them, so that within the shortest time in the exam, you'll be able to fashion out the questions correctly and you will come out with the right answers. And by the time you check your overall, that is your overall score, it will be remarkable for any higher institution of learning. So here, what I'm trying to say is that this question 10, you have the shaded region above is represented by the equation. Look at what you have. If you are to solve this kind of problem, the first thing you do is write out the solution to this graph, which is usually ax plus by plus c equals to 0. Take note of that. Then the question asks you to, the shaded region above is represented by what? So in this situation, we know that we have, then we make this solid formula whereby we have by to be equals to, this one comes in, become minus ax minus c. That means our constant is negative. So without wasting much of our time, if you look at the questions that we have, it's only one that has a negative a, and that is option C. So in this respect, you don't have the time in the whole world. So since this is the equation you consider and your a is negative, so you just go to option C. That's the one, because it is a critical point where your a is what? Negative, and that's option C matches that. Now, let's see question 11. This is also a graph. If you look at this very well, point where the curve cuts the x-axis will definitely be the what? The critical point. At this point, look at this. It's cutting the x-axis at what? -1. That means x equals -1. At this point, it is cutting the x-axis at the point where x equals 2. So if x equals to -1, it implies that x plus 1 will definitely be equals to what? 0. Then if x equals to 2, definitely x minus 2 will definitely be equals to what? 0. So when you have your y as the product of what you have, x plus 1, x minus 2, you can use your y will now be equals to this times this. Then in that situation, let's simplify this. Y equals to this time this x squared, this time this minus 2x, this time this plus x, this time this minus 2. Y will now be equals to x squared minus 2x plus x, that's minus x minus 2. So automatically, this will be the solution. So in that situation, we go there and see this is the solution, that is the representative of the graph that we have. So we go to our option and see the one that matches that. And that would be no other one than option A. Then, no other one than the option A. You have to be very careful because this one has minus minus, and you have minus minus. This one has plus minus, so option A matches that. Now, look at question 12. This is the one that is involving the absolute value. So take note of these questions, especially question 12 and question 13. There is a unique pattern of approaching this kind of question. So let's see question 12. That one says solve for x. We have absolute x minus 2 less than 3. Anytime you have something of this kind, what you need to do is to take the squares on both sides. That's to remove the absolutes. So when you take the squares on both sides, it will be x minus 2. It is only taking the squares that can remove this absolute. Less than 3 square. You square both sides, just like what I have done. Then you expand this. And the simplest way of expanding this is to place these 2 on x. That is what? X squared. Use these 2 to multiply x. That is what? 2x. 2x times minus 4. That becomes minus 4x. Then place these 2 on minus 2 squared. Minus 2 squared. Minus 2 times minus 2, that's plus 4. Less than. What is this? 9. Then we try to solve this. Transfer this one to this side. Then we have x squared minus 4x plus 4 minus 9 less than 0. Then we have x squared minus 4x plus 4 minus 9, that's minus 5 less than 0. So in this situation, we are looking for, so at this point, let's try to solve this one by factorizing. So if you want to factorize this now, what are our options? We have this multiplied by this, that gives us minus 5x squared. So what are the, we have 5 and 1. So the one that will give us the one in the middle, there will be minus 5 plus 1. That's minus 5x plus x. So anywhere we see minus 4x, we are going to replace with minus 5x plus x. So that will be x squared minus 5x plus x minus 5 less than 0. And we dissect this. What is common here? X is common. X into x minus 5. What is common here? Plus 1. X into x minus 1. So x minus 5 less than what? 0. So we have this case. Then we can now simplify this as what? X minus 5 x plus 1 less than 0. So that's what we're going to have. Then we can now solve this one by this times this, that's x squared. That means our a is greater than 0. So automatically we have a minimum curve where these are y and these are what? X. We have solved series of these questions, so I don't expect you to miss this kind of question in the exam, because we have solved so many examples to the point that you cannot afford to lose the marks on this question. Now you have this, then the critical values equates x minus 5 equals to 0. So our x equals to what? 5. X plus 1 equals to 0. X equals to what? Minus 1. Between x and between 5 and minus 1, which one is greater? 5 is greater than minus 1. So minus 1 comes first, then I have 5. Then you look at what you have. This is a positive region, this is a negative region, this is a positive region. But you look at this our graph, it is what? Less than 0. So which makes it what? Negative. So we shade the negative region. That means since we are shading the negative region, which lies between minus 1 and 5, then we have our x lying between minus 1 and what? 5. So we go to our option and see the one that matches this. So come to our option here, which is then we do option C. Then let's try and look at this last question here, which says that what is the solution of x minus 5 x plus 3. It is said that if one is not informed, one will be deformed. You can see the way I've succeeded in answering the question that has to do with absolute. I said square it to remove the absolute, then you solve it the way it is solved. If it's this kind, what you need to do is to check your denominator. what is your denominator? X plus 3. You are going to square your denominator. That's how to approach this kind of question. You square your denominator and use it to multiply both sides of the equation. So what am I saying? What I'm saying is that use this to multiply this. I have x plus 3 all squared times x minus 5 over x plus 3 less than minus 1 times x plus 3 all squared. Then if that is done, this one will cancel one of these. You have x plus 3. Then you have x minus 5 here. Then less than minus 1. Then this one, let's expand this one. This one will definitely be, put this on this, that becomes x squared. Use this to multiply this 2x times this plus 6x. Put this on this plus 9. So that's how to do that. Then let's expand this 2. This time this x squared. This time this minus 5x. This time this plus 3x. This time this minus 15. Less than, this time this minus x squared minus 6x minus 9. So that's what we're going to have. Then the next thing is, let's transfer all what you have got here to this side. By so doing, let's simplify this. X squared minus 5x plus 3x, that definitely will give us minus 2x minus 15 less than minus x squared minus 6x minus 9. So let's transfer everything. You have x squared, this one comes here, becomes plus x squared. This one is minus 2x, this one comes here, becomes plus 6x. This one is minus 15, this one comes here, becomes plus 9 less than 0. So in this situation, x squared plus x squared, that becomes 2x squared. Minus 2x plus 6x, that becomes plus 4x. Minus 15x, minus 15 plus 9, that becomes minus 8. No, minus 6. That becomes minus 6. So that is what? Less than 0. So what, if you look at what you have here, you discover that if we can, there is a common term here, or the common number, 2x squared plus 4x minus 6 is less than 0. So 2 is common, so I can bring that 2 out. I will have 2 into that x squared plus 2x minus 3 is less than or equals to 0. So let me divide both sides by 2. So if I divide this by 2, I will also divide this by 2. 2 can cancel this, then I have x squared plus 2x minus 3 less than 0 divided by 2 is still 0. Now let me now solve this one by factorizing this. The two factors here will definitely be what? Minus 2x squared. Definitely it will be 1 and 3. Which one will match the one in the middle? That's plus 3 minus 1. So I have x squared minus x plus 3x minus 3 less than 0. Then I can dissect this like this. What is common here? X is common. X minus 1. What is common here? Plus 3. X minus 1 less than 0. Then I have x minus 1. X plus 3 less than 0. So this is what I have. X times x, that's x squared. So automatically that means our a is greater than 0. So we have a graph of this kind, a minimum graph, where this is our y and this is our x. Then check for true critical values. X minus 1 equals to 0, our x equals to 1. X plus 3 equals to 0, our x equals to minus 3. Between 1 and minus 3, which one is greater? Minus 3 is lower than 1, or 1 is greater than minus 3. So minus 3 comes first, then you have our 1. Now, what are we talking about? Is it a positive or a negative? This is a positive region, this is a negative region, this is a positive region. The graph is what? Negative. So automatically, we shade the negative region. So we shade this region. And since the region links, that is, the value of x lies between the two critical values, then we can say minus 3 is less than x is less than 1. So we go to our option and see the one that matches this. Minus 3 less than x less than 1 is option A, and that is the answer.